Hello, we are going to discuss this question. Number of subsequence that satisfies the given sum condition. This question is from the lead code. And the one thing that I found very interesting about this question, so that I would be discussing very briefly. So coming back to the questions, just give you a glimpse of what is in the question. So question says that you are given an arrays and you have given a target and you have to tell how many subsequences you can make whose difference of the maximum value and the minimum value should be less than equal to the target. Okay, and whatever would be the value you have to give it in the modulo of 10 to the power 9 plus 7. So 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 we know that we're gonna be doing a two-pointer approach where we would have a left and the right, and then we would start from left from 3, and we have a pointer at 7, and we'll check whether 7 plus 3 is less than 9 or not. So it is not, then I would decrease the right from 7 to 6. Why it's so? Uh, because if we increase 3 to 5, if I increase left, then it would increase the sum. So to decrease the sum, because the sum is more, like 10 is more than 9, so that's why we increase the right side. So right side value is would be less uh, when we move it to the left side. So in that case, and then we do. So the very interesting part that is here is when we found, like there is something like 6 and 6 and 9 are less than 9, let's say less than equal to 9. So how we gonna find, like, how many subsequences are gonna be? So to count the number of subsequences, we basically do is 2 to the power, index of 6 is 2, index of 3 is 0, so 2 minus 0, so 2 to the power 2. So that is what they add into the answer. So how do we know that they're gonna be 2 to the power 2, like total 4 subsequences? So I have basically um, a very detailed. So let's say this is the input. Okay, let's say this is the input. So I'm basically answering that question only, like why we are required to 2 to the power 4. Why do we require 2 to the power 4? So this is a very good explanation where you could understand that why 2 to the power r minus l is required to be added into the sum. So let's say we have a target 9 and this is the input. So first case 2 and 7, 2 and 7 are basically would be the sum who's equal to the 9. So this, so 4 minus 0, 4 minus 0 to the power 4. So there are, let's say let's say we have four elements like 1, 2, 3, 4, and then we want something like uh, if we have four elements, then we can write a binary of it. Okay, so these are 2 to the power 4 ways. So these are 2 to the power 4 ways in which we can write something 3, 4, 6, and 7. Okay, 3, 4, 6, 7. If it is 0, 0, 0, 1, that is. So I'm basically taking this part only. This is, you could understand this 4 is from here to here. Okay. So if something like 0, 1, 1, 1, then it is 0 is this, 1, 1, 1, 4, 6, 7, 4, 6, 7. So whatever comes, this is the subset I have created. So that would be 2 to the power 4 subset, and then we would add 2 to all the subset. These are the subset that is created, and then we added 2 into that. So what would happen? Like 2, 6, 7. So maximum would be 7 and minimum would be 2, and the difference would always be less than equal to 9. So you can check. You can check. Similarly, the next would be 3 and 6. So 3 and 6 would be 9. So similarly, there are 3 minus 1 is equal to 2. So two elements would be there. So the binary representation for 2 would be these four elements to do. And if I write like 4 and 6, so these would be the different subsets, and then we add 3 into all of them. So these would be the subsets. Okay. So this is basically the answer. So 2 to the power 4 plus 2 to the power 2, we add it, and that would be the answer. So that is what we are doing here, answering some power of, and we are modding it for basically making it smaller. Okay. So thanks.